You're probably fine. So there's more than one pathway through each of these problems. But we're looking for our solution. And when we're dealing with a system, what kind of solution are we going to get? Are we just going to get an x equals? Think about when we have a system of equations. That means I usually have a line and maybe another line. Or maybe we have a curve. What are we going to get for a solution? Where is the solution on these two lines? Where they cross. So we're going to need our solution written as what? An ordered pair. X comma y. Solutions to systems are points. They're points. So all of our solutions need to be as points. So looking at this first system here, we've got two equations. What can we do with this? Yeah, we can solve this with substitution. I have a y equals equation here. I know y equals this, so substitute that in. We're going to set them equal to each other. We're substituting that 2x minus 1 in place of this y. So we're going to have our 2x minus 1 equals this guy, our x squared minus 4. How do I solve that? Why? I'm not saying you're wrong, but why? Because it's a quadratic, so we need it to equal 0. So I'm going to minus 2x from both sides. And we're going to add 1 to both sides to get 0 equals x squared minus 2x minus 3. How do I solve that? It factors. So we could use our x prime if we need to. Multiplies to be negative 3, adds to be negative 2. That's going to be a negative 3 and a positive 1. So our factored form is our x minus 3, x plus 1. So what are our x values? X equals 3. X equals negative 1. So how many solutions do we have here? 2 solutions. So that means I need to find both points y values. How do I find the y values? Sub it back into one of the equations at the top. And it genuinely does not matter which one you choose. I'm going to go with the linear because it's usually less work to think it. But you can use whichever equation you want. So I'm going to grab one of the original equations, that y equals 2 times my x, which is 3, minus 1. What is 2 times 3 minus 1?
4, 6, and then minus 1 is
5. Order of operations. 2 times 3 happens first. So 6 minus 1 gives us 5. So our first solution to this system is the point 3, 5. We've got to do the same thing for the other x value. You can use the same y equals equation. You can use the other y equals equation. It genuinely does not matter. I'm going to use the same one just because it's easier. Y equals 2 times my x of negative 1 minus 1. So what does my y equal? What is 2 times negative 1 and then minus 1? Negative 3. So our other solution is the point, negative 1, negative 3. So it's been a minute, but you've done these before. Questions on this one? Okay. So this one we solved with substitution. I'm just going to mark that up here. Substitution. What can we do on the right-hand one? Absolutely valid. If you want to do this with substitution, you could absolutely subtract 2y from the top equation and make this guy be x equals minus 2y plus 1. 100% a valid move. Totally fine. Let's do it. You could also do this with elimination, but we have another one that's going to do that, so we can practice that on the next one. Let's follow our instincts. Since I have x equals this chunk, I can substitute this into my other equation in place of this x. It has to be an x equals or a y equals to do it as substitution. It has to be a variable equals. You could 100% do this with our elimination, but you do not have to. So let's set this up. We're going to take our 2 times our replacement of x, which is negative 2y plus 1. And then we're finishing out this equation here with our plus 6y equals 4. What do we do next to solve this piece? This guy. Distribute. I need to distribute this 2 through. So we're going to have negative 4y plus 2 plus 6y equals 4. Then what? Combine like terms. What do we get? 2y plus 2 equals 4. And then, yep, subtract 2 from both sides. We get 2y equals 2. So what does y equal? Y equals 1. We still need to go back and figure out what x is. But now we have a handy-dandy equation that says x equals this. We can use this to figure it out. So we know our x equals negative 2 times y, but now we know our y is 1 plus 1. So what is our x going to equal? Negative 1. So our solution to this system is negative 1, positive 1. I'm going to place a little separating those two problems. Questions on either of those two? We did them both with substitution, which is totally fine. Questions on that? Okay. Sometimes we'll be given equations that don't work as nicely with substitution. Oh, like, let's say the next one. This one is not so pleasant with our substitution stuff. So what could we do? On which one? On the bottom one. Why did you pick negative 2 to multiply this whole equation by? So that we can eliminate out my y's. I need them to have the same number. And we usually like to do the opposite sign because then we can add and it's way less gross for our signs. You don't have to. You could do subtraction if you want to, but that makes signs super gross. I do not recommend it. So what I'm going to do is I'm going to take that whole equation, both sides of it, times -2. So the top equation I'm just going to copy down. My 4x minus 8y is -20. That's the top equation, nothing's changed. The bottom equation I'm multiplying by -2, giving us -10x plus 8y equals +2. This is how we picked that, to get these y's to cancel out. Because if I come through now, old school addition in columns, 4x plus -10x is going to give us what? -6x. Minus 8y plus 8y gives us what? 0. That's what we wanted to happen. It should cancel out. If one of our variables does not cancel out, something went wrong, we stop and reassess. How about -20 plus 2? -18. You do not have to write the 0y there, but since it's the first one we've done in a hot minute, I put it there. So now I'm going to drop that 0y because it has 0 impact on what we're doing. -6x equals -18. This piece should cancel out. Or a piece should cancel out. It doesn't have to be the y's. It could be the x's. So what does our x equal? Ooh, careful on your signs. 3. Our x equals 3. This is still a system. I still need to figure out what my y's are. It's not going to be as pleasant, but I can pick absolutely any of these equations up here to do a substitution to find my y. It genuinely does not matter which equation you pick. I'm going to grab the top one just because it's the top one and it's easy to grab. And what we're going to do is we're going to take our 4 times our x, which is 3, minus 8y equals -20. And we're going to solve this for y. So first things first, we need to do that multiplication. And I know it's super tiny down here. I wrote too big at the top. So we have 12 minus 8y equals -20. What do we do next? Subtract 12. We have minus 8y equals -32. What does y equal? 4. So our solution to this system is the point 3, 4. All right. The one on the right looks kind of icky, but we can do this. That's our solution here. What do we do on this one? Set them equal. It's a substitution. I can take this piece and substitute it in place of the y. Definitely meant to do that with a pen, but you know what? It's a vibe. So we have 4 over x plus 2 equals x plus 5. The heck can we do here? That is 100% what we're going to do. We are going to multiply by the denominator to make this not be a super gross fraction. To both sides. So we need to multiply it times the whole side. That chunk and that chunk will cancel out. So we're going to be left with just 4 on the left-hand side for now.
No,
What do we get on the right-hand side? X squared. 5x plus 2x gives me plus 7x plus 10. Then what? Subtract the 4. We need it set equal to 0. It's a quadratic. So we get our x squared plus 7x plus 6. What next? Factor it. What does this factor down to? Gorgeous. X plus 6, x plus 1. So our solutions, our x's, are -6 and -1. And again, you can pick either one of these equations to find your y values. I don't know why you would pick the first one unless you're feeling particularly mean to yourself. Use the second one. Way easier. -6 plus 5. -1 plus 5. 4. So our two solutions here are -6, -1, and -1, 4. Questions on solving them algebraically? Because that is the most complicated kind of system we're going to see, is when they either are quadratics or have quadratics in them. Couple other things we need to remember from Algebra 2. If we have all our variables that cancel out and we wind up with something false, like, I'm going to get an example, like if I wind up with 0 equals 4. So my x's and my y's canceled out. What would we have here? No solution. What if I wind up with something that's inherently true, like 2 equals 2? All real numbers or infinitely many solutions. Either way. Okay, so sometimes with systems, we will wind up with no solution or an infinite number of solutions. And that's when we get something that is inherently true. 2 always equals 2. No matter what x is, no matter what y is, 2 equals 2. There's no x or y involved there. If all my letters cancel out and I wind up with something false, I have parallel lines. They do not cross. They never cross. So we didn't have any that were in our work here, but we might see them on things, so it's important for us to remember that. We're going to do 2 more today, I think. Oh, no, we're going to do the next page. So we've got a little bit more to do. So, graphing and inequalities. It's been a minute since we saw these. You saw them a little bit in Algebra 2, but mostly you saw these way back in Algebra 1. I was like, we've worked things harder than this, but it's just one of those matter of remembering it and kind of blowing the dust off the mental storage. So when we are graphing lines, things like this, just make sure we're using like rulers and things best we can, if possible. So we're going to graph both of these lines. When we have inequalities, we have to graph it to find the solution. Like, there's not another way of writing it. The only way of drawing the solution is to graph it. So we're going to start with one of these. X plus y is less than 4 or equal to 4. So first thing we need to remember is, are we going to do a solid line or a dotted line? How do we know it's going to be a solid line? It has the equals to. If it has the equals to, we do a regular normal line. If it does not have the equals to, that's when we do a dotted line, kind of like an asymptote. It looks like an asymptote. So what we're going to graph as our line is just the x plus y equals 4. Lots of options for how to graph that line. You can do xy intercepts. You could put it in slope-intercept form. You could find points. You could make a t-table. However you want to do it. What are we going to do to graph this line? Subtract the x. So put it in slope-intercept form. Totally fine. We get y equals minus x plus 4. So where are we going to start? Positive 4. How am I going to find my next point? Say it again. Up and to the left is absolutely valid. We can go up 1, left 1, up 1, left 1, or we could go right 1, down 1, right 1, down 1. Plotting up our points. The more points you put, the easier it is to connect them up accurately using a line. So this is just the equation for equals 4. But I had an inequality. So how can I show all the spaces where my x plus y is less than 4? Yeah. This is when we're going to shade a part of our graph to be able to show the whole region where it's less than 4. Some of us will be able to spot it right off the bat. Some of us will put in a test point. If you pick any point that's not on your line, you can test it that way. So think about 0, 0. If x is 0 and y is 0, 0 plus 0 is 0. That is definitely less than 4. So this is in my solutions, which means all of these are in my solutions for this blue line. And I do tend to use things like highlighters or colored pencils. If you ever want colored pencils for that, I do have, I think I even have them out right now. They're on the table in the front. You also can just do like shading. You don't have to make it bougie. Then we do the same kind of thing with our other equation. So I'm going to take this guy and we need to graph this piece. So is this guy going to have a solid line or a dotted line? Dotted line. How do we know it's a dotted line? It does not have an equals to. So dotted line because not equals to. It has to be greater than. Cannot be equals to. We're still going to graph the line that is, helps if I write the equation right, 2x minus y equals 4. That's where we put our dotted line. But we need to make sure we put it as dotted. So what can we do to graph this line? Subtract 2x is absolutely valid. So we have minus y equals minus 2x plus 4. Divide everybody by negative 1. We're going to y equals 2x minus 4. So when we plot this line, where are we starting? Negative 4. So it's this guy down here. How do I find my next point? Up to right 1. Up to right 1. Up to right 1. The more points you put, the easier it is to connect them up and have it be accurate. Then we're connecting them with a dotted or dashed line. Like that. It's kind of like an asymptote. Or at least it looks like an asymptote. Then we need to figure out our shading because this one gets shaded too. I need all the values where my 2x minus y is greater than 4. So then, so go back, I always go back to the original. Let me get my leash pointer back. Go back to my original. So it's a little harder to spot them when we have x's and y's on the same side of the equal sign. When in doubt, pick a point to test. So think about 0, 0. 2 times 0 is 0. Minus 0 is 0. Is 0 greater than 4? It is not greater than 4. So is this point in the solution for the light blue line? So are we going to shade above the light blue line or below the light blue line? Below. So this is going to shade over here. So the solution to this system is this double colored area that's down here in this kind of double blue zone. There we go. Just trying to make it a little bit darker. So the solutions are all of the points inside this double colored area. Questions on that one? Okay. Then we have two kind of weird story problems. One is one we've seen it kind of before, and the other one is a weirdly worded one. So first thing we're going to do is we're going to remember how to do a story problem with the system, and then we're going to look at the weird one. So we've got that you're selling tickets for your play. Student tickets are $4, adult tickets are $6. You sell a total of 525 tickets, and you make $2,876. We want to know how many of each ticket type did we sell. What are we going to do to start? Set our variables. What do we want to use as our variables? S, I'm going to assume we're going to use S for our student tickets. And A for our adult tickets. You'd be very mean to yourself if you swapped them, so I highly recommend making them logical. If you want to use X and Y, that is absolutely valid. If you want to use S and A, totally fine. If you use something like S and A, you don't necessarily have to write down what they are. If you use something like X and Y, you have to write down what they are. I need to know which one's which. And I need to know that you know which one's which. So we're starting by setting our variables. Then what can we do? Yeah, I know how many total tickets we had. We sold some number of student tickets. We called that S. We sold some number of adult tickets. We call that A. And if we combine them together, that's when we get our 525 tickets. What else do we know? Gorgeous. Our student tickets are $4. So for every student ticket, we get $4. So if I sold student tickets, we'd have $8. If I sold 3 student tickets, we'd have $12. So we're taking that $4 times every student ticket. Same thing happens with the adults, but it costs a little bit more for adults. So we have our 6A. And we know the total amount of money we made for our play was $2,876. Then we're going to solve this however the heck we choose. You could do substitution. You could do elimination. Either way. So solve this. You can do this one. Give this a go. See what you got. I'll do it both ways. I'm gonna lock my screen. What did we get? How many students attended the play? 137. How many adults attended the play? 388. It genuinely does not matter which method you choose. I did both of them. We have substitution on the left, and I solved for A. I did elimination on the right to get my students. So, like, you can go either direction. It genuinely does not matter. You get the same answer either way. I just only did half of it on each of them because I wasn't going to finish it out on both of them. So it genuinely does not matter which way you go. You can go either direction. Whichever way works better for your brain. Okay? The last one I want to do, I do want to do the next one. This is a weirdly worded problem. It is a system, but it's kind of weird. It's our last one for today. So we have the perimeter of some rectangle is 50 meters, and we're trying to find the maximum area. So I have some rectangle somewhere that has some length and some width. We don't know anything about either of the sides. What do we know? The perimeter is 50 meters. How do I write that as an equation? 2L plus 2W equals 50 meters. We don't necessarily need to have the unit on there. And we're trying to find some relationship with the area. How do we find the area? L times W. I would really like to be able to smash those two equations together. What could I do to be able to put this equation somewhere in here? Yeah. So solve this for one variable. We can absolutely divide everything by 2 to get L plus W is 25. And then pick one. L equals 25 minus W, or W equals 25 minus L. Either way, then I can substitute this into here to get 25 minus W times W is our area. I'm going to multiply this out real quick so that we can see what kind of expression this is. If I have 25W minus W squared is our area. What kind of function is that? It's a quadratic. How do I find a maximum of a quadratic? Negative b over 2a, because we're looking for what point? Our vertex. We want our vertex, so you can use our axis of symmetry, which is also the beginning piece of the quadratic formula, the opposite of b, denominator, 2a. It's that beginning piece of the quadratic formula. So our negative b over 2a is going to tell us the x value of our vertex, which in this case is our w. What is our b? 25. Good. So we have the opposite of 25 over 2 times a. What's our a? Negative 1. So what is the width? (25 over 2) decimal. 12.5. So what's the length? We found our width now. What's our length? It is also 12.5. So what is the area? (156.25). Now we're going to put our units back in. Meters squared. Because this was 12.5 meters. This was 12.5 meters. So when we're talking about these perimeter area problems, it's weird and gross and awkward and super strange. Okay? I have a big wall of text to put up here that is on the announcement page. It has a lot of information on it. There is a worksheet for the last homework, not even in your textbook. I made you a worksheet. It's up here on the table. I'll pass them out while I talk. I do have the final exam review packets. They are this one, if you want it. Ow, static shock. That hurt really bad. Right on the fingernail. If you do not know if you're doing DC next semester, or if you know you're going to drop it, bring me your book. They're $300 and they won't let you graduate until you pay it. So, okay. Also, IU gives 2 hours for its final. Looking at it, honestly, you might not need it, but if I'm not going to say you can't have that time. So, if you do need that additional time, more than the pipe time gives us, we back up on a 5th period anyway, on final day. So, you're just going to hang out through A lunch, and I'll write you past B lunch if you need time. Okay, so we're honestly in a really good time slot to do that. So you don't have to stop, you can just keep on trucking to finish out that final. I'm still good at counting. Okay, so this is your last homework. It's okay. After this, it's all review. David, did you have a question? It is a thick packet, but it covers everything we need for the final. Also, look at the very last page of the packet if you pick it up. It would give you such gross fractions, I highly recommend against it. You can. It'll work, but you're gonna get gross fractions.
Yeah.
Say it again. You're just gonna have to pick. If we, for the most part, if we have coefficients on all the terms, you're gonna want to do elimination. If we have anything that doesn't, you can use substitution. We could have also done this the same way. Also works. Yep. Have a great rest of the day. I'll see you Monday. We'll keep working on stuff.
That's not really the truth. She ain't gonna see my face.
I'm going.
I'm not about to be here.